All right, let's get into it. We are talking about the first major evaluative tool that we take, which is, are we figuring out whether the data that we're looking at are divided? When Miller's talking about divided, what we really mean is we want to make sure that we're making a meaningful difference. To help clarify, throughout these videos, I'm going to give you a very simple vignette. Now, imagine, for instance, that you have a child. You have a daughter, 12 months old. You're concerned that there might be some early signs of autism there. And in this particular case, the signs we're looking at are the child's nonverbal, the child doesn't often smile or interact with people, and they have distant looks. So it seems like maybe there's no social connection going on. In these cases, we would definitely want to do some sort of intervention. We'd want to make sure that we're helping the client as much as possible. We're helping our child. But who do you turn to for help? How do you evaluate whether that treatment is effective or not? And that can be difficult. So first, we're just going to be talking about divided. Are we making a meaningful effect? Okay. Our first behavior analyst, we want to make sure that we have a criterion for success. So for us, what we would like to see is in any session, in any hour, in any day, we want a certain number of smiles. So let's just say we want the child to smile as a goal 8 to 10 times per day. I'm going to invite a number of different therapists in to work with the child and see their results to see if I'm going to hire them. So for instance, I'm showing you a graph on screen here. On the y-axis, remember y is high, it's the left axis. I'm showing you the dependent measure, which is the number of smiles. We have the x-axis, the number of sessions, and these are hypothetical data, what would happen in a baseline condition before we start therapy, and then in our first treatment condition, the during therapy condition. These data indicate that the baseline levels are very, very low. We have maybe 1 smile per day for 5 days in a row. And then after starting treatment, we see an immediate rise to 4 smiles, then 7 smiles, then 10 smiles, 10 smiles, 10 smiles. Would you hire this therapist? Well, these are really good data, and unfortunately, good data like these are really rare. The reason that I say these data are good is they have a lot of features that we're going to unpack as we go on. These data show that there's a very clear difference in the dependent measure. We see a dramatic increase in the number of smiles. The design, of course, is not very strong. We'll come back to that. But we see this big change. And not only is there a big change in the level of the dependent measure, the number of smiles, the goal that we're interested in, not only do we see that big change, but there's no evidence the behavior was getting better on its own, and there's no evidence that the treatment, because it is effective, there's no evidence that it's only temporarily effective. So these are amazing, but very rare. Let me walk you through another example. When we're talking about divided, this is another therapist. This is Dr. A. They do an intervention with our child. We have the same kind of setup here for the graph. We have the baseline condition. We have a treatment condition. We're tracking the number of smiles across time. And in our baseline condition, we had 1 smile, 3 smiles, 2 smiles, 4 smiles, 0 smiles. So low baseline condition. We also had in our treatment condition 4 smiles, 4 smiles, 1 smile, 4 smiles, and 2 smiles. Would you hire this therapist? I wouldn't, and here's why. There's so little difference between the baseline condition and the treatment condition. If you were to figure out the arithmetic average here, it's practically indistinguishable. I would have no way of actually knowing if the therapist made any difference whatsoever. In fact, I could take out this dotted line between those two conditions, between the before therapy and the after therapy condition, and I would be hard pressed to say that there even really was a difference, that it wasn't in fact the same condition. This could all be natural variability. That's a term we use in the field, variability, natural variability between conditions. So I'm not very convinced that this was an effective intervention. These data are not divided because there's so much overlap between those two conditions. And that's important because overlap is a kind of, it's telling us about this thing called effect size. Divided, or the overlap, is in essence the amount of effect or the amount of meaningful difference that we actually produced in the behavior. And wouldn't you want to actually produce a big and meaningful difference in the life of your client? Now, imagine you're going to look at another doctor. So just super quickly, Dr. B here has a higher average in the therapy condition. What we have here in baseline is 1 smile, or excuse me, 0 smiles, 3 smiles, 0 smiles, 3 smiles, 0 smiles. So it's very consistent variability there. And then during treatment, we kind of bump up a little bit to 4 smiles, 5 smiles, 3 smiles, 5 smiles, 3 smiles. So on average, we have gone up. Arithmetically, we've gone up to about 1.5 smiles more in the therapy condition. But would you hire this doctor? See, I'm not really sure that I would, and the reason that I wouldn't is because even though there's less overlap, there's still some overlap here, and what that means is the treatment effects, the differences are not that big, and I really want to have as big a difference as possible. If even there's a little bit of overlap, that's not enough for me. I want to make a big difference. And that's how, when we talk about divided, even if one point intersects, it's too many points. We want clear division between conditions. So just to quickly summarize, Miller says that data are divided when they do not overlap with data in the adjacent condition. And just a quick note throughout these presentations, throughout the course, remember that data are plural. Data are divided when they do not overlap with data in the adjacent condition. When we're looking at this change, when we're visually analyzing, we're only going to look at the last 3 points of each condition. Check out our practice activities for an example of what I mean by this. The reason that we focus on only those last 3 points in each condition is because sometimes treatment effects take time. Sometimes treatment may not be efficacious right away, and you have to give it an opportunity to actually change behavior. So we want to be a little bit patient and focus when we're visually analyzing on only the last 3 points in each condition, so we have an opportunity to see if the treatment has had an opportunity to take effect. In the larger field, we would say that we're looking to see if there's a change in the level of the data, say the level from baseline to treatment or from treatment to reversal. Or if we're talking about a multiple baseline, the change from one baseline to the first treatment or the second baseline to the second treatment. When we're looking for changes in the level of the data, that tells us if we're actually making a large and meaningful difference in the behavior of interest for our client. We want to make sure that we're making a big effect change, a big effect size, and we want to make sure we're supporting the client in the best way possible. So come on back, make sure that you join me for talking about stability and what that means in terms of understanding data.